guys. Today I am going to discuss about problems on fence. Problems on fence. Now, before going to solve problems on fence, first we should remember certain things related to fence. Already we have derived all those things. Just before that, if you want to solve a problem, you should remember this because there's a small difference between your fin problems and your composite wall problems. See, what are things you want to remember? See, matrix to be remembered. Here, matrix to be remembered while solving your fin problem. One is your thermal conductive matrix. That is same as that of your previous what you use for your composite wall. That is A into K divided by LA into 1 minus 1 minus 1 1. You know A is called area of the material, area of the fin. K is called thermal conductivity, length of the element, this one. And then convection. When you come to convection, we cannot use the same expressions what we used it in our composite wall. Here there's a different thing is that HE will be equal to H into P LE by 6 2 1 1 2. Perimeter, this is called perimeter. Perimeter, it will depending upon the given cross section. It's a circular cross section or rectangular cross section. Depending upon that, we should use your perimeter equation. Then element heat generation vector. This is very important. Heat generation vector. Q bar is called heat generation. You want to identify whether the problem Q bar is given or not. If not given, automatically take it 0. If it given, you should consider that. Next, element heat flux vector. This is one more thing. Q. Heat flux is called as Q. P Q LE by 2 1 1. This is one more equation. Then boundary convection vector. If convection is present, automatically this is also present. You should use this equation. Then apart from that, one equilibrium equation you should remember. This is as same as that of your previous composite one. K into T, H into T equals to F. But what is F here? F is called, one is heat flux vector, your heat generation vector minus heat flux vector plus your boundary convection vector. This you should remember. Now, we move to problem 1. First, I am considering a problem. Consider a metallic fin with thermal conductivity of 70 watt per centimeter degree Celsius, 0.5 centimeter radius and 5 centimeter long, extends from a plain wall whose temperature is 140 degrees Celsius. Determine the temperature distribution along the fin. If heat transferred to ambient air at 20 degrees Celsius with heat transfer coefficient 5 watt per centimeter square per degree Celsius, take 2 elements along the fin. That means one thing is clear. He is told that take 2 elements. You cannot consider one element. Take it 2 elements. Okay, when you said 2 elements, you should divide this entire given continuum into 2 elements. Now, what is given? See, if you observe here, what is this? This is called convection. Now, temperature is given. What is the ambient temperature? That is T infinity is given. Now, write down all the temperatures. Figure is not given. I have written a wall. It is extended like this. From wall, it has extended. That is 70 watt per centimeter square is the wall. This fin, your K value. Then convection is because the fin is surrounded by some ambient air, that is fin convection is there. That convection will be H will be equal to 5 watt per centimeter square per degree Celsius. T infinity is 20 degrees Celsius. Then to express this, I have written a diameter, that is 1 centimeter diameter. That means fin is a circular section. Now, what is the given? I have written everything here. K, the actual radius is given and converted to diameter. Length is given, that is 5 centimeter. T infinity. Now, first step, what do you want to make it in FEM? Say first thing, whatever the continuum is given, make it into finite element model. If you observe here, I can use, because it is a constant cross section, I can use a single element. But what is given, take 2 elements. Because of that, I want to consider it as a 2 elements. Now, what I am making 2 elements means, now 1, 2, and 3. I am considering as a 3 elements. 2 elements. This is 1 element. This is one more element. Now, node will be, this is 1, this is 2, and this is 3. What it will make, you should determine 3 temperatures, T1, T2, and T3. You should determine 3 temperatures, T1, T2 and T3. Now length of the element, consider from here to here, this is L1. Consider from here to here, this is L2. Now, what is the total distance? See 2.5 centimeter, 2.5 centimeter, 2.5 centimeter and 2.5 centimeter. Okay, 2.5 and 2.5. Why 2.5? Because total distance is 5 centimeter. I am doing into 2 parts, 2.5 and 2.5. Now T1, T2, T3 is the temperature, but known temperature is T1. T1 is given 140 degrees Celsius. T1 is given 140 degrees Celsius. T2, T3 I want to determine. That means unknown is T2 and T3 you want to determine. How to determine this? To determine this, what is the procedure? First thing, it is almost similar to your previous problem also. Elemental conductivity matrix. What is elemental conductivity matrix? That is elemental conductivity matrix. What is conductivity matrix? K equals to A into K divided by LE 1 minus 1 minus 1 1. Now here area. See, previous problem area we are assuming it is a 1 meter square, but it is a circular cross section. What is area? Area you should assume, you should calculate pi d square by 4 because diameter is given. Calculate, you are going to get 0.785 centimeter square. Now, after calculating this, now calculate your matrix. What is K matrix? A into K divided by L. A is 0.785 into 70, 2.5, 1 minus 1 minus 1, 1. You are going to get 29.11. 21.99. This is for first element. Similarly, you should calculate for second element. What is second element? Same thing. A2, K2, Le2, 1, minus 1, minus 1, 1. What is area? Area is same 0.785 because same constant cross section. What is K? K is 70 only because material property cannot change. 2.5 centimeter. Then 1 minus 1 minus 1 1. You may ask that, sir, you are doing in centimeter because everything is given in centimeter. I kept it same. Everything I kept it same. So if you want, you can convert into meter and do it. Otherwise, if you do it in centimeter, you can get the same answer because all the dimensions are in centimeter. Now, what is this here? You are going to get same values. That is 21.99 minus 21.99 minus 21.99, 21.99. Now, what is the notes? 2, 3 because it belongs to second element. Now, in this, what I had given? I had given, I am going to calculate global also. What is global means? Now, K I want to calculate. How many nodes are there? 3 nodes. What is global now? See, global matrix should be 3 cross 3. 1, 2, 3, 1, 2, 3. Now, what is your global matrix you are going to get? Just write it. What is your global matrix? See, 21.99 minus 21.99. This I am not explaining. Already previously I had explained. 0. Now, minus 21.99. 0. This value you have two values. 21.99 plus 21.99. You are going to get 43.98. Okay. Minus 21.99. Minus 21.99. And 21.99. This is what you are going to get it. This is called your global K. Now after K, what is the next thing? It is surrounded by a fluid or ambient air. That means a convection is there. There is a convection mode of heat transfer is also present because the heat is transferring from fin to the your surroundings. Fin to the surroundings. Fin to the surroundings or fin to the surroundings or surroundings from surroundings to the fin. Because of that, you should calculate convection matrix also. Convection matrix also. That is, what is convection matrix? He equals to PHLE by 6, 2, 1, 1, 2. Now, what is P? P is called perimeter. What is perimeter? Pi into D. How to calculate pi into D? Pi into 1 centimeter. That is, you are going to get a pi value. And directly you can use here pi, or I am using pi value is 3.142. Now, I calculate how to calculate P 3.142. H is given 5. The length of the element 2.5. First element 6. You can calculate, you are going to get this value. This is H1. He1. Now, similarly, you should repeat it for second element because 2 elements are there. Same value you are going to get it. What is this? Pi into 5 into 2.5 divided by 6 into 2112. If you repeat it, you are going to get same value because no values will be changing. Only thing is, you make it as a 2 elements. That's it. 6.5, 13. That is 2, 3, 2, 3. That is your 2, 3 and 2, 3. Now, after this, what you want to make it? You want to calculate global matrix. How to calculate global matrix? Once again, H is equals to how many number of nodes? 3 nodes. 1, 2, and 3. 1, 2, and 3. Now, what is this? 13, 6.5, 0, 6.5, 0, 13 plus 13, 26, 6.5, 6.5, 13. If you want, you can check it. You are going to get like this. This is what you are going to get it. This is your H matrix. Now, you got H matrix, you got K matrix. What is the next step you want to do it? You have to do it for, next step is, you have to go for calculating your force vector. See, force vector, because what is your equilibrium equation? Just observe your equation. Equation is K into T plus H into T equals to F. Now, what is F? F I previously discussed. F will be 3 elements will come in F. One is your heat generation, one is heat flux, one is convection. In the present problem, what is given? If you observe in the problem, it is only given convection. See, this is not given. This is 0 and this is 0 because there is no heat flux matrix. There is no heat generation is given in the problem. Q bar and Q is not given. Only given is convection. Now, because of this, F will be equal to FHE. That is what he written. Then what is FHE? See, FHE for element 1. FHE for element 1 because to convection is completely surrounded, correct? That is, what is that? H into P into LE into T infinity divided by H into LE into P into T infinity divided by 2 into 1, 1. Now, substitute what is H value? H value, you know that 5. P already you have calculated. What is P? P is equals to pi into D, 5, correct? Into, what is your length of the element? For length of the element is 2.5. Then what is T infinity? 20 degrees Celsius divided by 2, 1, 1. If you calculate this, what is the answer you are going to get? Just observe, you are going to get 130.9, 130.9, 130.9. This is for element number 1. Similarly, repeat same thing for element number 2. If you repeat for element number 2, same value you are going to get, that is 130.9, 130.9, that is for node 2 and 3. node 2 and 3. But what is required for me? Global. What is global? That is for completely 3 nodes. F is equals to, what is that? F is equals to R. F is equals to FHE for complete. This one will be written as 130.9. 130 plus 130 because only one value is there. 2 nodes, 2 values is there. What is that value? You're going to get 261.8 and 130.9. That is your 1, 2, 3. Now you got F, you got K, everything you know. Now write it in a global matrix. What is a global matrix? First K matrix, write it. What is K matrix? 21.99 minus 21.99, 0, minus 21.99, 0. What is this value you are going to get? 43.98. 43.98 minus 21.99 minus 21.99, then 21.99. This is your K. What is temperature you are going to get? T will be equal to T1, T2, T3 because 3 nodes. T temperature you are going to get. H value will be equal to, just write what is H value you got. 13, 6.50, 6.50, 13, 26, 6.5, 6.5 and 13. Is it correct? Yeah. You are going to get this. Then what are the temperatures? T1, T2 and T3. This is equals to, what is F? F is equals to 130.9, 261.8 and 130.9. This is what your equilibrium equation. Now, if you see here, these two are similar, say 3 cross 3 matrices. Now add it. Before applying your boundary condition, first you should go for adding it. Now that is I am going to explain here. What you want to add it? If you add both the matrix, what is common? See, common is T1, T2, T3 are common. T1, T2, T3 are common. Now what is this side? If you should get K plus H, you should write what is K plus H. Just observe what is K plus H. If you add both the matrices, this value becomes 34.99. That is 21.99 plus 13. Then next value become minus 21. That means minus 15.49. Then 0 plus 0, 0. Then minus 15.49. This is also 0 because symmetric nature. Then this value, if you check it, you are going to get 63.48. That is 43.98 plus your this value. What is that value? I think this is, you are going to get is, just observe this, what is the value you are going to get. Maybe I have made a small mistake here, I think so. What is the matrix? Just observe here, H matrix. H matrix, if you observe here, 1, 2, 1, 2, correct? 2, 3, 2, 3. That means 2, 2 means 13, 13, 26. Okay, 26 only you are going to get. What is that value? 26 means, what is the value you are going to get? Just check it in the calculator. What is the value you are going to get it? That is, what is the value? 63 point, not 63 point, that is 43.98 plus 26, you are going to get 69.98. This is 69.98. Okay, next value if you make it minus 21.99, that is minus 15.49. Okay, then here also minus 15.49. Then here if you make it, you are going to get, that is 34.99 is equals to, what is the values you are going to get? This is 130.9. Then you are going to get 261.8. Then you are going to get 130.9. This is what the value is. 1, 2, 3. This is 1, 2, 3. 1, 2, 3. Now if you observe here, given condition is T1 equals to 140 degrees Celsius is given. That is known thing. So if this is known thing, then if what you want to make it, you want to eliminate first round, first column. If you want to eliminate first round, first column because T1 is known. Then you have to reduce your matrix. If you reduce your matrix, just observe what happened. If you reduce your matrix, see this is 69.98. The matrix will be modified, minus 15.49, then minus 15.49, 34.99. What is the value here? You are going to get T2, T3, this you want to determine, is equals to, just observe now, 261.8, 130.9, but here 0 into T1 is 0, no value will come. But if you observe here, second equation, you cannot write like this because this equation is a different. What is equation? Minus 15.49 into T1 is there. Because of this term, we cannot directly neglect this term because previous problems, even if you solve your structural problem, displacement is 0. If you multiply it, automatically is 0. But in this kind of problems, you should be careful. Minus 15.49, you have to re-alter it to this side. If you send it minus 15.49 to this side, what happens? It will become plus 15.49 T1 plus 15.49 T1. Now that means if you modify it, what happened? 16.98 minus 15.49 minus 15.49, 34.99. This is T2. Then T3 is equals to, now just check it what happened. This is 130.9. This value become, what is that value? That value should calculate it. What is that value become? 15.49 into, what is the value? 15.49 into 140 plus 261.8. If you do it, 2430.4. 2430.4. Now solve it. How to solve it? Use two equations are there. 69.8 into TH minus 15.49 into T3 is equals to 2430.4. Then minus 15.49 into T2. Then plus 34.99 into T3 is equals to 130.9. See, if you solve these two equations, if you want to solve it, you have to make similar values. That means T2. See what you want to multiply it. So if you multiply, if you want to get 34.99 divided by 15.49. So if you multiply for this equation, 2.25, multiply for 2.25. If you multiply 2.25, what happened? It will check it. 69.98 into 2.25, that is 157.45 into T2 minus 34.99 into T3, because if you multiply, that is 15.49 into 2.25. if you multiply 34.85 or 34.99, you can make it, okay, is equals to 2430.4 into 2.25. you are going to get 5468.4. Now this equation as it is, you write it, multiply only for that, T2 plus 34.99 T3 is equals to 130.9. Now if you solve this equation, this and this will cancel. Now what happened? 157.49 minus 15.49, that is 142 T2, 142 T2, not 142 point something it will come. That means it will be 49. Now 141.96 it will come. 141.196 is equals to this side 5468.4 plus 130.9 plus 130.9. This will become 5599.3. 5599.3. If you calculate, T2 will be equal to divided by 141.196. If you calculate it, you are going to get 39.65 degrees Celsius. 39.65 degrees Celsius. Okay, that is what you are going to get it. If you see it is 39.65 degrees Celsius, now you got it, T2 is 39.65 degrees Celsius. Substitute in any of the equation. I'm going to use equation number 2. That is, what is that equation? Minus 15.49 into T2 plus 34.99 into T3 is equals to 130.9. Now this will become, just I'll make it, 34.99 into T3 is equals to 130.9 into, that is plus 15.49 into T2. Now if you calculate what is T3, just observe here, 130.9 plus 15.49 into what is the T2 I got it, that is 39.65, 39.65, that is 745. I'm going to get 745.078, and that is 34.99. Now T3 will be equal to, divided by 34.9, and if you make it, you're going to get 21.2 degrees Celsius. That means T1 140 degrees Celsius is given, T2 is 39.65 degrees Celsius, and T3 is 21.2 degrees Celsius. This is how you should calculate a temperature for fin problems. This is how you can calculate temperature for fin problems. Thank you.